Okay, so chapter 4. We've looked at and used chemical reactions a little bit, and I'm sure you've seen them before in classes or online, different places. So they're not completely new to us, but we're going to begin to use them um, comfortably now in class all the time. So um, we see a chemical reaction like this. The arrow shows us the separation between the reactants and the products. Okay, we could kind of think of this as a language, and we're saying two HCl's, hydrochloric hydrogen chlorides, plus calcium carbonate, right? One, there's no coefficient always for ones, correct? See, there's no coefficients for these, but there's one of them, right?
Yeah, I get that.
So um, two of these combines with one of these. This means like to form, or this and that react to form, or results in. One calcium chloride, one water, and what's that? What's that, Fred?
Carbon dioxide.
Carbon dioxide. Good. Our states, solid, liquid, gas. What's AQ again?
Dissolved in water.
That's right, it's dissolved in water. HCl, when it's dissolved in water, is what?
What do you mean?
Well, this is hydrogen chloride, but when we see that it's aqueous, we can say that it's hydrochloric acid, right?
Oh, yeah.
And hydrochloric acid, is it a strong acid, a weak acid?
Um, where do we find that out?
Well, on the back of your periodic table, um, there's a list of your strong acids. So here I have our strong acids, right? Um, so you can see, is HCl on here?
Yeah, it's on there.
Okay, good. It's on here. We have it HCl, meaning that if it's a strong acid, what do you have in the solution after you add HCl to your solution?
Um, Strong acids completely dissociate.
Very good. So HCl, if it says aqueous, what that means is I have the hydrogen ion, which is aqueous, and the chloride ion, which is aqueous. All right, and they're separate from each other in something that's a strong acid, because again, that's strong strength of acids is an indication of to the degree that they separate. Another compound like sodium chloride, which is completely soluble, all right? So if it says aqueous like this, then what that means is sodium ions and what else, Fred?
Chloride ions.
Chloride ions, right, are aqueous in solution. I don't have any of that stuff actually. It's these ions that are separated. So sodium chloride aqueous, we write it like that, but we have to know that it means that those ions are dissociated from each other. All right, so aqueous, solid, liquid, gas. Great. So we want to be able to balance these equations. Now, to balance an equation, there's no special mystery, just a little bit of an accounting tool. So if you have your own accounting tool that you like, that's great. To balance an equation like this, we can only change the coefficients. Do you remember what the coefficients are?
I think I do, but why don't you tell me?
Well, so this 8, 18, 2, 2, 2, those aren't the coefficients. Those are the subscripts, right?
Yeah.
And the coefficients, which would be in front of here, why don't we have any coefficients in there?
Well, you do. They're just all one.
That's right. These are all 1. Coefficients are 1. There. Good. Thank you, Fred. So here's an example of a chemical reaction, H2O, this being decomposed into hydrogen gas and oxygen gas, all right? We want to make sure that the number of elements on the left equals the number of elements on the right. And so what we do is I kind of make a little separating line there, and I list all the different entities on the left and on the right. Identify how many there are. How many hydrogens do we have here on the left, Fred?
2.
All right, so 2 hydrogens. I'll put a little equal sign there to separate it.
And 1 oxygen.
1 oxygen. Now over here,
Um, 2 hydrogens.
yeah, this represents 2 hydrogens here. What's this?
2 oxygens.
2 oxygens there. Good. Okay. So now I need to make changes. Oh, there's not 0 though.
Yeah, I know. I don't know why you wrote that.
There's one oxygen. Good. So I need to change coefficients to balance this out. So I need more oxygen on which side?
The left.
More oxygen on the left. So if I put, I can only, I'm very limited in what I can do with coefficients. I can't go 1.1, 1.5 permanently, right? I can use that temporarily sometimes, and we'll see that. But eventually, so, all I can do is change that to 1, 2, maybe 1.5 or something like that. But that's only going to be temporary. It has to ultimately be a full number. So 2 here will then change, and so I put a little slash in both of those because I know that it's going to change the number of my elements. So how many hydrogens do I have now?
You have 2 water molecules.
2 water molecules. That's right. And each water molecule has a hydrogen in front of it, or it has 2 hydrogens, so that's 4 hydrogens. All right?
Thank you.
Oh, yes, no problem. Oxygens. How many oxygens do I have?
2 water molecules, that's 2 oxygens.
That's 2 oxygens, yeah. So again, this 2 H2O means I have 2 of these H2Os. All right, each one has 1 oxygen and 2 hydrogens. So there's 4 hydrogens and 2 oxygens if I have 2 of them. And that's what this represents here. All right, on this side now, things aren't balanced. All right, I didn't change anything over here, so I don't change these numbers. But what can I do here?
You need more hydrogen.
I need more hydrogen. So to get 4, I have 2. I can put a 2 there, right? And then that'll change that to a 4. I don't need to cross out that because I haven't changed anything. And now I'm balanced. Okay? So I have my equation here that I balanced, just going back and forth. All right? So that's pretty much how we do that one. All right. You want to try to balance this equation here, Fred?
I think I got it. I think I can.
All right. Well, give everybody a chance at home. Push pause. Take a second. See if you can balance it. All right. So I'm going to set up my, I'm going to write my equation down. C8H18 plus oxygen gas going to carbon dioxide and water. All right. And my coefficients are 0. On the left, I have what elements?
Carbon, hydrogen, and oxygen.
Carbon, hydrogen, and oxygen. On the right, the same ones?
Yeah.
Okay. How many carbon do I have on the left?
That's 8.
That's right. That 8 is showing me that I have 8 carbons. How many hydrogens?
Just 18, right?
Yeah, 18. That's what that number is showing me. How about the oxygens?
2.
Yep. Okay. How about over here?
Only 1 carbon.
Okay.
2 hydrogens and 1 oxygen. 3 oxygen.
3 oxygen. Very good. 2 from here and 1 from there. Okay. So I can choose to start anywhere. If I start with my carbons. Now, one thing that you will learn over time is if on either side I have something that is elemental, meaning there's just one kind of element in that that state. In this case, it's a molecule, right? It's usually going to be a molecule, but if I save that to balance that for last, I have everything else balanced. It'll be easy to balance that because I just change one number and it just changes one thing, one element, right? So I'm going to save that for last. And if you don't remember that, that's okay. It's not a big deal. You'll realize it as you do lots of practices. So C8 looks like I'm going to put an 8 in front of here. Is that okay?
Yeah, that's right.
That changes my carbons and my oxygens, so I need to go back and look at those. So I have a total of 8 carbons now. And how many oxygens?
You have 8 CO2s. That's 16?
That's right, 16 oxygens. Good. Okay. Now, this is not balanced. Oxygen's not balanced. Hydrogens aren't balanced, though. I'm going to save oxygen to last again because it's by itself. What can I do to balance the hydrogen?
Put a 9 in front of the water.
That's 9. You knew 9 because we have 18 here, right?
Yeah.
So 9 is going to change the hydrogen and going to change the oxygen. So I'm going to need to see here, 9 times 2, that's 18 hydrogen. And now oxygens, I have, 8 times 16 plus 9, is that right?
Yeah.
So is that 25, is that right?
Yeah, 25 oxygen.
Okay, so again, 8 times 2, 16 oxygen here, plus that 9 oxygens here, 25 oxygens. All right, excellent. Now I can go back here and everything's balanced except for the oxygens. What number has to go here?
Let's see. If you put 12, it'd be 24, right?
Yeah, so you're seeing if I put 12 here, it'd be 24, but if I put 13, it'd be 26.
Yeah, you can't do it.
All right. So we've found something here that we're close, but we can't get it exactly. And it seems a little frustrating for us. Well, what I suggest doing is putting in here the fractional number that would work. So what number would work perfectly?
I don't know. What do you mean?
Well, if I take 25 and divide it by 2, right? Because there's 2 oxygens on in each molecule. If I put 12.5 in here, then that would balance my equation. See that?
Can you do that?
Well, you can't leave it like that, but when I do that, that will make this, changing my oxygens, it'll make it 25, right? Now everything's balanced in this statement here, but to get rid of these half uh, or fractional coefficients, I can see that if I just multiply this by 2, it'll become a whole number. And then I can just multiply all these coefficients by 2 also. So I'm going to multiply everything by 2. This is going to be 25. This is going to be 2. This is going to be what?
16?
16. And this one?
18.
Okay. All of these numbers go by 2 as well, right? Oh, this is 36, huh?
Yeah, 36.
And this is 50. There we go. Okay. But that shows us that we can balance this equation by, that this is the balanced equation. 2 C8H18s plus 25 O2s goes to 16 CO2s and 18 waters. Okay, good. Hopefully you took that chance to practice that and you followed along there.